Today we will learn grain size distribution of coarse aggregate. Aim of the experiment is to determine grain size distribution and fineness modulus of coarse aggregate. Apparatus required: Indian standard test strips 80 mm, 40 mm, 20 mm, 10 mm and 4.75 mm. Refer to IS 460 1978. Weighing balance, sieve shaker, trays, drying oven. Materials required: coarse aggregate. Theory and scope: aggregate larger than 4.75 mm sieve is called coarse aggregate. When the aggregate contains different sizes of particles in suitable proportion, it is called a graded aggregate. This graded aggregate improves the workability of concrete. Sieve analysis of aggregates is done to determine the proportion smaller than the different size of particles and is given in terms of percentage of total aggregates passing through each sieve size. The results are plotted on a graph with ordinates showing percentage of aggregate passing of finer than a particular size, while the abscissa shows the sieve size on logarithmic scale, and the resulting curve is known as grading curve or gradation curve. In order to ensure the presence of all sizes of particles, the property of aggregate called fineness modulus is defined. The fineness modulus represents the massed average size of the sieve on which the material is retained, the sieve being counted from the fineness. Procedure: the sample is brought to an air dry condition either by drying at room temperature or by heating at a temperature of 100 degrees Celsius to 110 degrees Celsius and cooled. Next, the air dried sample of coarse aggregate is then weighed accurately. Next, the sample of aggregate is sieved successively on the appropriate sieve starting with the largest in order 80 mm, 40 mm, 20 mm, 10 mm and 4.75 mm over a clean tray for a period 2 minutes shaking. Next, the shaking shall be done with a varied motion backward and forward, left to right, circular, clockwise and anti-clockwise, and with frequent jarring so that the material is kept moving over the sieve surface in frequently changing direction. Next, material shall not be forced through the sieve by hand pressure. Lumps of fine material, if present, may be broken by gentle pressure with fingers against the side of the sieve. Next, lumps of fine material, if present, is to be broken by gentle pressure with fingers against the side of the sieve. Next, find the mass of aggregate retained on each sieve taken in order. This figure shows you Indian standard sieves. Table 2 is representing grading limit for coarse aggregate IS 383 1970. Observations and calculations. Fineness modulus of coarse aggregate is equal to summation of cumulative percentage retained plus 500 divided by 100. Result: 1. The given sample of aggregate conforms to grading requirement of single size or graded aggregate of nominal size. 2. A particle size distribution curve or grading curve is plotted with ordinates showing percentage of aggregate passing or finer and the abscissa showing the sieve size on logarithmic scale, that is a semi-log plot. The grading curve indicates whether the grading of a given sample of aggregate is too coarse, too fine or deficient in a particular size. Thus, A. If the actual grading curve is lower than the specified grading curve, the aggregate is coarser, indicating the possibility of segregation of the mix. B. If the actual grading curve lies well above the specified grading curve, the aggregate is finer, indicating greater water requirement. C. If the grading curve is steeper than the specified grading curve, it indicates the access of middle-sized particles and may lead to harsh mix. D. A comparison of this curve is made with the standard curve for single size and graded coarse aggregate. Conclusion: the experiment has an important bearing on the concrete mix. From the result of sieve analysis, one is able to proportion the fine and coarse aggregate in order to get combined mix of required gradation. Reference: 1. IS 2386 Part 1 Method of test for aggregate for concrete particle size and shape. 2. IS 383 Specification for coarse and fine aggregate from natural source for concrete. 3. IS 460 IS Specification for test chips.